What you'll see in this video is a full tutorial where I go over every single step for creating this design. It's a toroidal shape, it's an array and has some twist. So there's a few things here for you guys to learn if you're into parametric design or architecture or just want to learn the process for creating these scripts. So thank you very much for being here, and let's jump into the tutorial. So the first thing we're going to do is bring in a circle. So let's go here, double click, and we'll bring in the circle component. Now the circle component has the plane input and the radius. So we can use the default, which is the XY plane, or we can create our own XY plane and even plug in a point to move it to a different location. So now that we have this, let's plug in the radius. Let's create a custom slider. We'll go 0 less than 30 less than 60. So now we have a slider from 0 to 60, and now we can set it here. Now for me, what I like to do is I like to bring in a scale person so I can see exactly the size that I'm making this. And since it's going to be like a pavilion or an architectural space, we want to make sure that we keep the scale correct. So let's insert this file. I'll also have this on my website to download, so you'll have this scale person that is already perfectly scaled to place into your model. So now we're going to rotate this around. Now we'll see that this is kind of the size of the pavilion that we're creating. Let's actually put him in the middle here. Okay. So now here with our radius, now the radius is 36, which means the diameter is twice as much. Just keep that in mind. All right. The next thing we're going to do is create a surface or a plane reference so we can create our geometry here. So let's go here, and let's keep in mind that if we are to bring in a perpendicular frame, we can use a curve input and we can extract a perpendicular frame. What that'll give us is the ability to use that frame to create our geometry. So let's plug this curve into the curve input, and the parameter is going to be, well, from 0 to 1. So let's go here to 0.500. And you'll see that it actually moves it by 0.5 or 1. Now, to make sure that, let's say this is right at the beginning, we could keep it at 0, or we can reparameterize this curve so it goes from 0 to 1, and then we can pick a location. So 0.5 would be halfway, or 0 would be the initial point. All right, now with this frame, let's bring in a circle component. Now at this stage, you can bring in any type of geometry here and use this frame as the plane input. I'm using a circle, but you can also use a polygon. So with this radius, let's go here to 15.5. So now it's a slider from 0 to 100, and we set it at 15.5 here. So what this does is it creates that geometry here. Now, obviously we can just sweep it if we wanted to. So use this section, and the rail would be the initial circle. But what we want to do is, rather than just creating this toroidal shape, we're going to create a different geometry here, and we're going to do the same thing for the sweep. So let's unplug this, holding down Control, and now this circle we're going to divide, but we can also do horizontal frames. And we can also set this, let's say, at 0.5. Or the other way to do this, actually it would be perpendicular frame. What we're going to do is divide this curve. Now let's change the size here. And now to create circles or another set of geometries that overlaps it, we need to create a plane reference in the same way that we have this plane reference. So when we look at this, we see the X, Z coordinate. So let's do that. Bring in an XZ plane and place it right at those points. Now we can create another set of circles. So I'll take this, copy it over. These are going to be smaller. So if they're the same size, they're going to overlap at that center point, or we can decrease the size here. Of course, we can always, which I didn't change here, change the number of subdivisions for the points. We have 10. Now where it starts is this point and then it divides it. So that's something to keep in mind. If you want to change that location, then there's a few other things that we can do. Now that we have this, well, we can take our circle and these circles and we're going to put them together. But one thing to keep in mind is that I'm going to hide these frames so they don't kind of get in the way. When you have these reference planes, they're actually pretty big. So with that, let's take this and this one and use region union, which is the Boolean union of the two-dimensional world. So we'll use this circle as a curve input, and then this circle as the curve input for this. Now, if you see them still not being joined, then you need to flatten the input to make sure you only get the outside. So let's now disable the preview on this, and let me show you some of the cool things that happen here. So now you're seeing that the shape can change according to the size of the circles that we create at the points. Now with this one, I like to use a fillet so we can round off these bits. So I'll use a small slider, so 1.25, which will go from 0 to 10 and give us 2 decimal points here. Now you'll see that there's a limit to how far you can go, but even then this would actually create a cool shape where it kind of goes to a indent here and it's smooth. So those are the cool things that we can kind of discover as we create a script, is the opportunities that we sometimes don't think of when designing. So let's say if we get this close, well, obviously that's not going to work. It's got to be a little bit smaller or less subdivisions and a bigger fillet. All right, we'll keep it here at 6. So it's actually symmetrical this way. Lower this. All right, so we've already set the stage. So why don't we just take this component, bring it down here, and then set it into the segments, to the sections. Now at this point, I do like to sometimes go to a custom preview and just give it a color swatch, just so we can see what it looks like as a solid. And this is a typical array. Let's see. Some of these changes, when you sweep it, it does take a little bit of time, but so now we're just adding more or less, right? At 1 and then at 10. For now, let's disable the preview on this, or let's unplug that. We'll keep that to the side. And now let's go back to this and let's take this all the way around, but let's make sure that we keep this frame in mind. because we actually have to array this all the way around, including this frame, so we can use that as a reference to rotate the entire form, and then at the end create kind of this twisted toroid look. So with that being said, let's get into it. All right, so now that we have the shapes, let's create a polar array. In the past, I've shown different ways of doing this polar array, but this component can take care of the things that we need to here. The first thing is where do we rotate this relative to? Well, we need to use the original plane as the rotation plane. Then we can rotate these frames and we can plug in a specific number. So now let's go here to count. We'll say 15. Well, let's create a custom slider here. 0 less than 15 less than 30. And guess what? Once we have this, we're actually going to be doing the same thing for the form. So this, we have these points, and then copy this down. Okay. All right, let's lower this one because it might be a little too big for what we're trying to do here. So this one. Okay, now we're going to be taking these. Let's just see what it looks like when you loft it together. So we won't be doing sweep because sweep is a consistent sweep around. This will actually be a loft. But notice it goes from the beginning to the end. So how do we close this? Well, right click on options, close loft, commit changes. All right, let's disable the preview on this because we're going to be, before we loft it, we're going to be rotating it relative to the center of those. So as I said, rotate component is the first thing we'll use. Which planes? Well, we rotated those and they're corresponding with each and every single one of those. So we can use that as the plane input. And the geometry to rotate is going to be these sections that we arrayed all the way around. Now notice here that when I change the angle, let's say 45 degrees, it'll actually do it the same thing to all of them, all at once. So the question is going to be, since we don't just want to rotate all of them, how do we rotate them all the way around depending on how many we have? Let me show you that. We know how many objects we have because we have 24 arrays, which means that we have to create 24 different rotations that increase by a specific number. Now, if that's a little confusing, let me show you how this kind of works. So, first thing is, when you rotate something, we are rotating it a specific amount. So if we want to rotate it once, that's actually based off of 360 degrees. So bring in a panel with 360 because that's how much we're trying to rotate. You can also do a slider. Let's just do that. 360 divided by, if we want it to go all the way around, so we divide it by how many we have. So we're going to divide it by 25. So it has to increase by 14.4. So if we know that we have it an increase by that much, then we'll use a series component because that'll help us create a step using that number. So a series component stepping by 14.4. And we want to create how many numbers? Well, by default, we have 10, but here we actually have 24. So this number becomes what you divide by and the number of copies you have. So now we have 25 different angles starting at 0, 14.4, and increasing by 14.4. I do like to hide the wires just so it doesn't like overlap and get confusing, but you can see when you select the component, it actually goes to that one. And it rotates all the way out to 360, and it'll say down here. So with that being said, we'll use this series as the angle. But there's one thing to keep in mind is either right click here and go to degrees, or change it from radians to degrees. So now you'll see that we're rotating 360 degrees. The less we have, the less rotations we have. But you'll be able to see that at the end here, it's difficult to see the slight changes in angles here unless you loft all of these at the end. So let's do that. Loft it together and preview what we have here. All right, that was the issue. Rather than using radians, you just need to use the angle here. So that's kind of the issue there. Yeah. So now that we have this, we can see that 360 is the max because that's going to be how much you rotate it, but you can also multiply this. So if we do 360 multiplied by 2, we'll say maybe we'll bring in a slider of 3. So you can see that you can multiply 360 by however many turns you want to have. All right, so that part was confusing. What happened is, for some reason, when you plug this into it as radians, for some reason it's not working. So when you do series, just have to make sure that you right click and do that angle. Okay, so now that we have this, let's see here. All right. The next part we're going to do is take this and create the verticals that are arrayed here. So what we'll do is we'll go back. Let's delete this and let's actually plug this in. So now what we need to do is take the original circle and then offset it, or maybe just multiply it by 2. So if I bring this up, and we take 39 times 2, well, it'll always be offset by a larger number or twice as much. The reason we do this is to divide that curve in a different frequency than we did before. So we can do, let's say 40. And now we're going to go from the midpoint to those. So line segment from the origin to these endpoints. All right, now that we have these line segments, let's project them onto that surface. So project a curve into a B-rep. So this one. Onto which B-rep? Well, this surface. And the direction by default is going to be up and down. So this is how we can subdivide that form. And of course, we still have the overall form here, so it's kind of in the way. But now you're seeing how we can create this kind of turning shape. To extrude them perpendicular to the face that they're on, we need to do this. Extrude, or move, sorry. We're going to move these first using amplitude, which means we'll use the perpendicular of this surface. Now it won't let us do that. So we actually need to use then these planes. The amplitude is going to be, let's say, 1.5. And we actually need to do this divided by 2 because we're going to be extruding to both sides, which will make it twice as large as this number. So if we divide it by 2 for now, we could move this and then extrude it. Let's see, it moves it. We have to graft this, so it does it to every corresponding face. Hold on, these vectors are these. We can't use the other faces, the other frames, because there's less of them. So what we actually have to do is just evaluate this each surface. So evaluate surface. MD slider to extract the midpoint, and let's reparameterize that. Okay, so now once we do that, we can use that frame as an amplitude frame. And like we said, let's say 1.50 and divide that by 2. Because we're going to multiply it by 2 later. That's this one. We don't need to graft because it's already grafted. And then extrude by twice as much, like I said. So this times 2 in the negative direction. Now we can plug this in. So this extrudes relative to the center of each. All right, let's get on to making this an architectural space inside. So look, we extruded this, which was this surface. And this surface is created from those curves. So what are we going to do? Take those curves, create some space here because we're going to be designing in this area. We're going to offset. Let's try that again. Offset curve. There's a lot of them, so it's going to offset all of those at once. Now we have to do it in, well, it's offsetting to the outside, which maybe that's okay. Maybe that's the inside face of the structure, but typically we would actually offset it the other way to make it the dimensions that we use as the actual dimensions, and then it can go to the inside. So let's go here, 1.5 again. Now here's the thing I'm going to do though. Since we have so many, I'm actually going to just go here and decrease the number that we have. Let's go 30 here for now. Okay. Actually, it's going to be, let's see. These offset relative to the planes that they're on. So all of those are relative to this frame. Now it's working here. Okay, so now I'll disable the preview on this and this, or wire display. For this reason, we have this one offset by 2, and we'll just do this one offset by 0. So there's this one, the original, and then the offset. So now we can try this boundary surface between those two. And so let's now unplug our preview. Now we have these surfaces that we can use this number. All right, let's extrude it. We'll take this and override this one. So now we can extrude relative to. Let's do that again. Let's take all of this. Down here and use this input. Now we can use this output, which is going to be the solid frames. Now some of these things may be a little bit confusing, so if you want to download the script, just go to the website. It'll be there until the next video is released, so you can see exactly how things plug in if you have a hard time. Sometimes these do get a little bit complicated, so I totally understand. Okay, let's go back to this and let's disable the preview on everything except for this and our custom preview, so we can see things a little bit more. Okay, so it's taking shape, but let's change this now to a bigger number, 50. Okay. The rotation might be a little too much here. So rotation by 0 or by 360 here. Yeah. So we have this loft and it's a closed loft. So this is what we're going to do. We're going to create a box and we're going to move this box down in the negative direction here. So Z, negative. And then let's go to, say, 60. All right, now this is going to be the difference. So Boolean difference, solid difference between this lofted and this. So now the more you lower this, the ground plane will kind of go down with it. And this is what we're going to be using to do the intersecting portion. So this now we can disable the preview here. We can see how this is developed. Now let's put the person in here. Let's use our mouse here. little bit too large, so let's decrease that. This is the outside. This is the inside. So now let's loft that one together. Lofting this, flatten, set boolean to true, or set close loft. Well, actually, it's just going to be this one. And so what happens is we're seeing that since we offset to the inside by 1, let's offset to the outside by -1. So let's go here. Negative. So offsets to the inside and to the outside by 1. Now we can take this part, do a custom preview as well. This time it'll be something like this. All right, I see one thing that I want to add, and it's the floor here. So what happens is where we trim, where we subtract, we'll see here, it's basically this box. This one. Where this intersects with this, you'll see, we need to extract that information. So here under the intersect tab, physical, vrep, and brep, where this box intersects with this, oops, wrong one. I did transform rather than the box. So here we have what it looks like from the ground level here. So now we need to extrude this up by 1 times 2. So this will create a surface. And then this will be moved up by this times 2, because we offset to the outside and to the inside. So times 2, 1 times 2 equals 2, which this then needs to be moved up in the Z direction. Or is it just 1? It's just 1 because it's from the original location, just 1. So that was a mistake. Okay. So with that information, let's disable the preview on the box because the box is just a reference. And with this surface, we'll extrude it up to create the floor material. So let's go. Bring this down here. And we'll extrude this object in the Z direction by, we'll say 0.5 or so. Now I'll do wire display hidden, and you're seeing that I do this just to keep it organized here Obviously, it gets tricky once you go along with the script, but we're trying here. So, okay. Let's do this. And our last custom preview is going to be here. So I'll bake this so we can put that guy up. Bake this so we can bounding box this guy and just move him down to that surface. So move vertical down to, see if it lets us pick that, and change our lens length so we can view this a little bit more comfortably. So, oops, we'll delete this and we'll take a look at how the space kind of looks like from the inside here. So yes, we have our twisted toroidal shape that comes all the way around and actually creates some cool spaces. Let's say like this, where you could actually go here on the side. Maybe that could be a location where there's an exit to the outside or to the center portion. So hopefully you find this, like I did, a really cool exercise on form finding and also developing your architectural designs using parametric tools. Like you see, there's a lot of plugging in and tying together information, but once it clicks, you'll be able to figure out how to program your own designs. So if you want to download this, go to my website. It'll be there temporarily, like I said. And so what I'm going to do now is organize this into the labels, so all the sliders are going to be labeled, and then see if I can turn this into a cluster so it could be organized just by inputs and outputs. So thank you for being here. Hopefully you found this interesting, not too confusing. If you want to download it, go to the website, and I hope to see you on the next one.